this little lecture I'm giving here, it's not just telling you how to use default dict. We're going to go deeper. Why was it designed the way it was? Could we design it differently? If so, what are the implications of that? All right, now I'm going to talk about default dict in some detail here. Like I said, we talked about this a few weeks ago in one of the mentoring calls among other collection types in Python, and default dict comes from the collections module. And to motivate, here's the kind of code situation where it might be useful. So this, well, I can't select that text, but here, this is the shortest poem I know that is actually interesting and enjoyable. Beauty is truth, truth, beauty. Sure sounds nice. So let's use this. And let's say I'm going to write a program whose job is to do some analysis of text. And the analysis I need to do specifically is to count how many times each word appears in a corpus or in a group or in a text, okay, in an input. And so what I'm going to do here is I have one that's a little bit cleaned up already, so I can just split it. And I just have a list of words. So that's what this is. So this words variable is going to be a list of beauty is truth, truth, beauty, those strings. And the algorithm to count could look like this. I create an empty dictionary for word in words, and then I need to check, is this word in the dictionary called counts? Because if we have not encountered it yet, as we scan through linearly, it will not be in there. And if I attempt to increment it, then I'll get a key error, is the exception it raises, if I attempt to execute this line when word is not in the dictionary. So I insert it, and I insert it with the count 1 because we've seen it so far. And by the end, we have the correct counts, okay? Now, what default dict can do is allow us to take these 4 lines and compress them down to 1. So I import it from the collections module. It's in Python standard library. And look carefully at how I create the default dict. Now, default dict actually inherits from dictionary. So it's a more specific kind of dict that adds some functionality. And I'm actually going to show you some code about how you would implement it, because this little lecture I'm giving here, it's not just telling you how to use default dict. We're going to go deeper. Why was it designed the way it was? Could we design it differently? If so, what are the implications of that? How would you actually implement this in Python code if we didn't have this tool in the standard library? We're going to get to that. But first, we're going to show how it works in some situations it's useful. And it's useful in the very basic word counting algorithm that we have here, because what we do is we instantiate it, and notice carefully the argument we pass in. Open parenthesis, int, close parenthesis. So we're passing a type object in here. We're passing the int object, which is a type that's built into Python that can be called like a function, because in Python, classes are callable. There's no new keyword. So a class and a function have the same interface in how you work with them in that sense. Okay, so to create a new integer, we could say int, open, close parenthesis. But we're not doing that here. We're passing this type object as a parameter to the constructor of default dict. Got it? So the next thing we do is say forward in words, and then we just boldly assume that it's in here. So the behavior of the default dict is this. If it acts in all regards like a regular dictionary with a couple of differences. And the difference is that if you think about what this is doing, right? This is what this line is doing, is merging 2 operations together. It's looking up what the current value of a key is, and then it's going to add 1 to it, and then insert that new value for that key. So it's really 3 operations, right? All in one line. So when you do this with a default dict, if the word is already a key in the dictionary, it acts like a regular dictionary would, no change whatsoever. The difference is when you have when word is not in the dictionary already, because a regular dictionary would raise key error here, but here's the procedure that it does. What it does is, actually, let me see if so what it does is it will, if the key is not in the dictionary, it will take the function you passed in the constructor, invoke it with no arguments. Okay, so that's what it's doing. And that invoking with no arguments will return a value, which when you call int with no arguments, can anybody tell me what that value is it returns?
0.
That's right, 0. So that becomes the current value, okay? And it actually inserts that as a side effect. So it says word square count square bracket word is set to 0, but it's actually going to add 1 here because we're using plus equals 1, and then it'll set to that. So it's going to be 0 plus 1 becomes the new value. You get the logic here? So again, to contrast it with the regular dictionary, this will actually, if you reference it, so this is dict, not default dict, and you reference a key, you get a key error, the specific exception. But if you reference with a default dict passed in with int, if you reference a key that's not inserted, then it will create that manufacture, that value, the default value, but calling int with no arguments, insert it in the dictionary as a side effect, and then return it. So see what it's doing here? This is quite different from the behavior, and it's useful when we have algorithms that we do want to say, well, if a key's not here, we want it to set it to this dictionary. And like I said, you can, or excuse me, set it to this value. And like I said, you can use it with any, in all other respects, it behaves like a regular dictionary. Okay. Now, let's talk about the argument to default dict. The argument needs to be callable. Okay, so what are the things that are callable in Python? Let's make a list and tell me, take yourself off mute and tell me what is callable in Python. Like we have functions, right? Basically anything that can be called like a function. Okay, functions are callable. In Python, class objects are also callable, because if you have a class called capital something, how do you create an instance? You type capital something, open parenthesis, and then the arguments to the constructor, close parenthesis. That's the same syntax as calling a function, right? And when you get to next level Python, those of you who've gone through that know that you can actually make instances of your class callable by defining a special method called dunder call. So this concept of what's called callability is important in Python. It basically means anything that can be called like a function. So that's the argument that we pass into default dict. It must be callable, and more specifically, it must be called with no arguments. Okay, so if you pass in a callable that requires an argument, then you'll have errors because default dict will call it with 0 arguments. Okay, so quiz. How would you create, knowing all this, so all this is straightforward enough, and many of you knew what I've talked about so far. Here's my question. How would you create a default dict whose default value is not 0? Because we know how to do that, right? Default dict parenthesis int creates one that is default value of 0. And we can pass in other things like float. We call float with no arguments. It returns 0.0 like we have here. Or string, str, we call that with no arguments. It returns an empty string. How would you do a little bit differently though? How would you create a default dict whose default value is 1, the number 1? Go ahead, Mark.
Just create a function that returns a 1.
Exactly. Very good. You create a function that returns a 1. Like this. Def1, open close parenthesis, return 1. That'll work. And then we have that function and we pass it in as the argument to defaultdict. Defaultdict, open parenthesis, 1, the word 1, meaning the function called 1, close parenthesis. We're not calling 1. Every time a key is referenced that does not exist, 1 will be called. This function called 1 will be called. So here we have a key foo, a key bar, a key baz that is not actually we assign to it. So we don't need to fall back to a default value for that. But for foo and for bar, we do. So that means it will be called twice. Once when we reference foo, next when we reference the key called bar. It's not called again when we reference baz because we're inserting the key value pair. Therefore, there's no need to call it. But it will be called multiple times, once every single time individually, whenever you insert or reference a key that does not exist. So can you see how this can be useful to generalize? You could say, well, I want an instance of some object that I want to put as a default value. Or I want to put in some other like 2.7314 for some reason that you want that floating point number to be the default value. Whatever it is, as long as you can write a function for it, you can put it in. And in fact, this is also useful for a lambda expression. Instead of writing this function, we could say lambda colon the number 1, very brief. So that creates a lambda expression that takes 0 arguments because that's the format here. That's the interface here. So we say lambda colon and then the default value. All right. So any questions or comments about this so far? Okay. Now, here's my question for you. Why do you think it was designed this way? Because defaultdict, which is, put in the standard library by some very skilled core developers, right? Why do you think they chose to make it this way where its constructor takes a callable? Don't you think it would make more sense in many use cases to have a default value instead? So instead of saying defaultdict parenthesis int, you could say defaultdict parenthesis 0 because that's a default value, or parenthesis 1 if you need a default of 1. Why do you think they chose to make it this way?
My best guess is that it allows for you to access some definitions in the environment or something, so the behavior could depend on the code base that you're running it in. But for most purposes, most use cases, it would make sense just to return 0 or 1 or something rather than
like
have
I said,
a call.
Yeah, I think it's interesting. I think the use case you cited there, I think, are you talking about where the default value changes after the defaultdict is instantiated?
No, so
just read the environment variable or whatever it was and set the default value, then configure the defaultdict object. I like how you're thinking. So
what's the term for functions catching the variables that are defined in the same namespace? There's a word for it.
Namespace, sorry.
There's a word for the way that functions capture variables that exist in the namespace that they're defined in.
I think you mean global variables?
Yeah.
Or you mean outside the process?
Outside of the function itself.
Outside of the function or outside of the running program?
Outside of the function.
Outside of the function, yeah. So at the top level, you can define global variables, and those are visible, at least readable, and can be set to be writable as well with the global keyword. But basically, they're visible anywhere inside the module. It should be called not global, but module global. Then we have a refinement, which we talked about a few weeks ago, called non-local, but we don't need to go into that level of detail with it. So there's a better reason for this, though. That's a good thought, but I want to actually stimulate you all to, because I don't want you to just be able to use the tools that exist. I want you all to be creating new tools that don't exist, that are really awesome and valuable and make you very popular and famous because people like to reuse them. That's why we're doing this. So why do you think, let's invest a little time thinking about this. What's another reason that you can think of where they might decide what's another reason they might have decided to design it this way?
You might be having a complex object or class that you want to create.
Elaborate.
Well, in a dictionary, I mean, maybe you're adding people records or something. You have a person class that you want to create. If that person's not already in there, you know, you're keying it by their name or social security number or something. And maybe you're adding complex objects to the dictionary. And that class can also interpret, you know, override adding or something. I don't know.
You're very, very close. You haven't quite hit it yet. No, you're very close, because what you're getting at is that maybe you don't want to insert the exact same object every time, right? Because if they designed it to accept an object instead of a callable that generates an object, because remember what I said before, here when they access foo, that will call the function called one and return an object and insert that key value pair. And then when bar happens, is referenced, it also again calls the function, inserts a key value pair. But if they designed it so that it took a default variable instead of a callable, then it would simply insert that default value in each one. And if you're just an integer, that doesn't matter. But what if it's an instance of a people class? Then you have the same object with the same ID, the same instance being referenced by two keys. And that may not be what we want, right? But the constraint with this is that we couldn't create a people instance or person class instance, I guess is what it would be, with that is parameterized by any information, because it must be called with 0 arguments. So you're really close. Do you have anything to add with it, Mark? Or did that trigger anything?
Well, inside your callable, you can set values so that everybody gets their own instance.
Can anyone think of an example where it would be valuable to do that? Where it would be, with this example, it doesn't matter if the number 1 is inserted in each one, in each key value pair. But can anyone think of an example where it would matter a lot?
So a list, like a mutable.
Yeah, list.
That's exactly right. A list. Check out this example. So let's say we wanted to make an example of a list of foods that are really popular in different countries. I got to go to Gdansk, Poland, which is in the north of Poland, and teach. Actually, I was teaching DevOps to. There's a big Intel headquarters there, and I was teaching them that for a week. And so I got to eat a lot of great Polish food. And one of my favorite foods there was zupa, which is just their style of soup. Then in Australia, they have macadamia nuts. And in USA, we eat burgers, and there's some other foods here. So the point of this object here called foods, it's a default dictionary that has a list of foods. So the keys are country names and the values are lists of foods. Okay. So here we have Poland.append. So list, well, actually, let's back up. List called with no arguments generates what? An empty list, right? List called with no arguments generates an empty list. And then we have, so when we reference food square bracket Poland, then Python will say, okay, there's no key called Poland, so I'm going to call list, open close parenthesis, that returns an empty list. I'm going to insert that value for the key called capital Poland, and then return that from the expression. So we have a list, a reference to a list object that we then invoke the append method on, inserting Zupa. And then we do the same thing for Australia and then the USA. And then when we get to Australia again, we already have a key value pair. We already have a key called Australia in there. So it returns that list object, and then we append to that. So now it has Zupa, it has, it has macadamia nuts, and it has meat pies in it. And then the same thing with Poland. Okay, so then we can, then when we go through, we see all this. Let me ask you, let's imagine that default dict took not a callable, but just a literal list object. What would have happened then?
So it's a particular list that has an object ID, and then every time you append, it's appended to the same list. It's the same problem as the keyword, using a list and a keyword in Python.
Yeah. You mean, or I think you're referring to like a default argument of a list.
Yeah, default argument as a list.
Yeah. Same exact, exact same problem, right? So yeah, so if we had this, if default dict had a different design where it took a literal object and that literal object was a list, then Poland would have, the first reference to Poland would have assigned that list object. And then basically you're appending a value to every single list. So all of these would end up, USA, Australia, and Poland, all of them would have all the foods. Okay, so that's why it was designed this way, because it allows you to do things that you could not do by taking a callable, then allows you to do things this way. So now, the next thing I'm going to tell you about is how you would actually implement something like default dict. Before I do that, any other questions or comments about what we've covered so far? Okay. Let me prepare. Screen share. So here's how you would implement default dict. Okay, so why would you implement default dict? You would not. You would just import it from collections. But I'm teaching you how to reinvent the wheel so that you can create other wheels that do not exist yet. It's part of the big value of learning to reinvent wheels. So I'm going to import from collections, but I'm going to import something else. I'm going to import user dict. We talked about this when we talked about collections a few weeks ago, but essentially this is a mix-in class, meaning it's not meant to, it's basically just a bundle of methods, and that's all its purpose is. So it's not meant to convey anything about the type hierarchy in the spectrum of general to specific that you normally have in an inheritance chain, right? Instead, what we're going to do is we're going to have user dict, and user dict is going to be a mix-in our class called my default dict, so that it brings in certain useful methods. Okay, now what this does, this will pull in a bunch of methods that are used to implement the interface of a dict in Python, And it's going to center around self.data. So that's a actual dictionary that is brought in by userdict. So userdict includes this attribute self.data, and it includes methods that operate on it. And one of the methods that we're going to override is called dunderGetItem. DunderGetItem is the one where you actually reference when you're asking what is the value associated with the key in the dictionary. So if you have a dictionary called X and you say X square bracket some key name, then that dispatches to calling the method called dunderGetItem. Does that make sense? So we're going to override that, and there's other methods like dunderSetItem. When you assign, if you say X square bracket key name equals value, that triggers another method called dunderSetItem, and we're not going to use that. We're going to, we're not going to define our own version about that, because userdict defines a version of that that is exactly behaving like a normal dictionary, and we're just going to rely on that. Okay. But what we're going to do depends on an attribute called default factory. Now, let me explain this. Default factory is an argument we're going to give to the constructor of our class called myDefaultDict. And we're going to set it on self. And then we need to call the constructor of userdict to add all the additional methods we're going to use. Okay, that's what that line's about. And in dunderGetItem, what we're going to do, so we have, remember that basically if you say X square bracket some key, if we reference it, that translates to a method call. Essentially, when you write this, that's Python perceives it as this. Okay? This is a magic method called dunderGetItem. If you go in the Python docs and look at the data model section in the language reference, then it'll tell you more about that. But what we're going to do is check, is this key in self.data? Because that's the source of truth. That's the actual key value. All the key value pairs are stored in self.data. And if it's not in there, we're going to insert it. Self.data square bracket key equals a value. And the way we're going to get that value is by taking self.defaultFactory and we call it like a function. We call it like a function. Self.defaultFactory should be callable, just like with defaultdict, like int or list or the function called one or whatever we put in there. And we're going to call it with no arguments. This is what a defaultdict does essentially. Behaves just like that. So a side effect is we create this default value by calling default factory, and then we insert it for that key. Now, whether this if condition evaluates as true or not, by the time we get to the last line of this method called dunderGetItem, we do have that key defined in self.data. So we simply look it up and returned it. And so then if we run our program, it produces the same output as what we saw before. So any questions about this? If I run this on the command line, then this is the output it produces. Any questions or comments about this so far? All right, so let's look at another variant. How would you change this? If let's say I actually want something like defaultdict, but I don't want to pass in a default factory. I don't want to pass in a callable. I want an actual value that's a default value. And yes, Aaron, I heard your arguments against that. I understand. I don't care. I just want this behavior. So you want to pass in not a callable that generates new values, but you want to pass in as a constructor, you want to pass in an actual default value. How would you modify this? How would you, let's start with the constructor. What would you change in the constructor?
What was the question again?
The question is that this implementation of my default dict takes a argument that is a callable that is going to be called with no arguments to generate default values. But let's say you don't want that. You want the more simplistic definition, or let's say simplistic behavior of, instead of a callable, you just want to flat out pass in a default value. And whenever it references a key that is not inserted yet, it will just insert that value. That's what you actually want. What's the first thing you might change here?
I think you can still have a variable that you pass in
Yeah,
that captures the thing, but you don't call it with the parentheses to make it callable. Just
yeah,
use it.
that's actually exactly right. So let me show you what it looks like. Basically, the constructor is the same, really. All I did was rename the variable. So instead of default factory, it's default value. But if you compare them, other than that rename, they're identical because it's just stashing an object on self. That's all the constructor needs to do, and then call user_dict.dunder in it. But then it's just like you said, Tim, instead of calling open close parentheses on that object that we stashed on self, it just passes it without. So that's the only thing that's different.
Well, wouldn't you have to worry about, well, in this case, it would work, but wouldn't you have to worry about them pointing to the same thing, like as in the case of a empty list or something?
Yes, it suffers from that bug. Yes, that's exactly right. And that's why the standard library version does not do this. Yep, exactly right. See, it's interesting. I've kind of enlightened you by explaining that, right? So now you can't go back. Now you can't go back like before this session, or maybe you knew already, Mark, but a lot of people before listening to this may have thought, well, I wish it took a default value instead of me having to figure out a function that'll return the value. But, you know, once you know why and what the benefits are, you see it as superior, right? So that's a good point.
I think our discussion we had some time ago about labels on values was a good understanding of why they're all pointing to the same thing.
Yeah. Yeah. That's a very important, yeah. That's one of the first principles of Python. I'm always talking about the first principles of Python. That's exactly right. That's a good demonstration of it. All right, so now let me show you, actually illustrating your point, Mark. Here's that version, the same one I just showed you, but I'm using it on the list example. Okay, so this code right here, exactly the same as what you just saw. Okay, but but now the example, what I'm doing is demonstrating why it's not desirable if your default object is a list. If we insert the foods here, then what's the output? There we go. See, this is the output. See how it's completed? Basically, it's the same list. That's the downside of this approach. That's why we don't do it.
If you did ID on those also, would it?
If we did like print of, let's see, food. So it's mapping country is the key. Food is the value, which would be the list. So you're like that, right?
Yep.
Let's do that. What do you know? It's the same ID for each one. Pretty interesting, right? I think this is interesting. What do you guys think?
Yeah.
All right.
Callables rule.
Yeah. Absolutely, they do. It what I love about this is that it's such a beautiful, it's also a good demonstration of where the function object abstraction is useful in Python. And it's actually more general than that, because the function object abstraction, it's like the callable abstraction, the callable object, meaning int, it's not a function. Int is a type or a class, because in Python, classes and types are there's no distinction between the two in Python, but like there is in some other languages. But int is something that's not a function, but it's callable, meaning it's called exactly like a function. So we say and we talk a lot in next level Python, higher order Python, about how the function object abstraction is so important. And I call it the function object, but really it's the callable object abstraction. So meaning functions or method objects or types or anything with a dunder call method.
So if you go back to your food example there, and where you're setting it to the default value, if you wrap that with a copy, wouldn't that
like
fix
here?
it for the simple case? No, up in the get item.
Oh, like that?
Well, can't you wrap the outside of it
That
with
would work
copy?
for some types. The thing is, like, a lot of types have a copy method. So more general, but not everything. So more general would be import copy, and then we could say copy dot, maybe deep copy would be more appropriate.
If it can't
Is that what you're talking about?
Yeah.
Yeah. So for anyone who doesn't know, so there's a module called copy in Python standard library, and it has a function called copy. So it's copy.copy, and copy.copy does a shallow copy of the object. So if you have a list of, if you have a dictionary where mapping keys to values, like basically if you have a nested data structure, it will only go one level deep of nesting. But if you want to recursively create copies of all levels of nesting, that's what deep copy is for. So that might be the most generally safe thing to put in.
I think it's still better though. This is
interesting because it's essentially using a prototype model, right? Whereas the real default dict uses a callable, and what we have here is saying that the object passed into the constructor is a prototype object. Pretty cool, huh? Pretty interesting way of thinking about it. Okay, but it's actually more general to do it the way default dict does it, because what you can do, go back to that, modify it. Let's say I'm going to define something called new value. And then we say, well, actually, no, I need the food example for this. Let me do it this way. Okay, so let's revert back to victory. Okay, and then do the. Okay, so this is let's call this mydict3. Okay, so this is a new implementation that basically behaves like the my default dict version 1 did, and the default dict does, but we're going to mutate it here. So instead of a list, I'm passing in, let's say new value. Okay, I'm going to define a function called new value with no arguments. Now, if I just say return this, then that is exactly equivalent to this, right? However, I could do something that says, say false, let's say something called prototype, okay? So it's going to be a list here, but it could be, and you wouldn't bother if it was just a list, but let's imagine it's a more complex thing. What I could do is I could say return copy.deep copy prototype and have that in. So basically I'm taking the, I'm taking the default, let's get rid of all this.
What if in prototype, to make it a little more clear, if you had its first item be like time.time?
Oh, that'd be interesting. Yeah. Okay, so let's go back to this and do it demo5.py. That's not a great example. Let's call this here. I'm just going to make a completely new.
I think it worked better with the list, putting a, because you're just appending to it. But yeah, when you're using integers, it's a little bit harder to.
Yeah, well, I'm just having to invent on the fly here a completely new example. But maybe like going back to the list, are you talking about?
It's prototype equals.
What were you saying about
time.time with the first value?
Oh, okay. Let's see. Yeah, okay. Let's say so items equals this, items dot append time.
Well, I would even put it up in the prototype.
Oh, that's what you're talking about. Okay. Got you. Okay. Like that? Yeah, yeah, you can do all sorts of fancy things, right? So, you know, we're talking about basically we're talking about a really simple example just so I can fit all the code on one screen and explain all the nuances of what I'm explaining in a short period of time. But I hope you're all seeing that this extends to, because everyone in here is essentially everyone in here is working full time writing code or something very close to that. So that means you're dealing with real world complexities that are way more complex than will fit on one screen that can be shared, right? That's the code you're dealing with. So can you all see how this is flexible enough to accommodate? And the whole point of this example of the program is to show you that if we did want to have, because there's basically three conceivable models that we've mentioned so far for a default dictionary. One is the one that's actually implemented where it takes a callable that is a factory for new values. The second concept is to take a literal default value. And now we have a third concept, which is a prototype, and that we implemented in this previous version using, no, I didn't actually save that as a separate file, but you know, the way that what would be done. Yeah, it seems like I unfortunately overwrote that file, but that was because I was creating a bunch of files fast and furious here. But basically, we are going to create we have a prototype model, and the first version, which is what in Python standard library, can implement all of these. It can implement the prototype model that creates copies of a prototype. It can create literal values. We say def something and return a literal. It accommodates all of these and even more than we're not even talking about. That's why I think it's an absolutely brilliant design. What are you all thinking? Any questions, comments, thoughts? What were you going to say, Tim?
But whichever, even if you're using prototype, you do it via callable, right? So you define it. Yeah.
Yeah. So that's, yeah. So what yeah. So basically the method they did choose of the callable version of this allows you to implement a prototype based pattern for this, but it would not work the other way around. If they say we're using a prototype, you could not implement a callable version, right? It would be, this is the most general and the most one with the greatest abstract expressive power.
Yeah, I agree.
And I think default dict is a really useful tool to know about in Python's standard library. But much more, I think it's a great demonstration of a well-designed component. We should all aspire to be creating classes and functions and types and etc. in our code that are as useful as this. So that's why I wanted to really dive into this and the design decisions behind this, not just how to use it, but why was it designed this way and why is it a good thing? What were the alternatives that could have been done instead? What are the trade-offs of all these? Because studying this helps us become better as developers. So I hope you enjoyed this. Any other questions or comments? This is all I had. Any other questions or comments from anybody here?
It's interesting to me because for a lot of people, the default value will be something like 1 or 0 or, you know, and in those cases, using int, making it callable and getting the default return value of that versus just hard coding the value itself makes no difference.
Yeah.
But it's these like edge cases where, yeah, you actually want an object, you want to have a different object ID, then yeah, it gets much more useful.
Yeah. Yeah. So I
That's
think
cool.
I'm actually going to post this whole thing I just did on YouTube. So I think this will be valuable on the YouTube channel for Powerful Python. I think it'll be really valuable for people to see. So yeah, so really good comments. So we can move on. I can elaborate. I can answer any other questions or comments about it. Any other comments or questions about this? Any other considerations or anything else you'd like to talk about today?
I just wanted to add something.
Yeah.
It makes more sense why we use the field when you're doing like data classes, and that's the default factory when you do the list.
Wait, I'm sorry. I'm not sure I follow that. When you're talking about data classes, say that again.
So when you want to add when you're making a list,
Uh-huh.
and use the field function when you're defining a list, the default factory list.
Yeah, that's actually, yeah, you're right.
Yeah. So it ties into that.
It ties into that. Yeah, that's a really good connection. Yeah, this pervades Python. That's why I work so hard to teach you all to do think of these abstract patterns, because there are such highly leveraged hook points for using these ideas that just pervade everything in Python standard library. And you're right. You're absolutely right, Jamie. It ties into that. Very good insight. So what else can I help you all with today? How did you like this? Oh, go ahead, Mark.
Oh, I was just saying this default dict is a good reminder of there's a common pattern where you're saying, where you're either having it a regular dictionary return a default value when you do the get, or you're saying if not in there, then do all this initialization stuff and then add it to the dictionary. Whereas the default dict is just so much simpler. I keep forgetting about it.
Yeah. Yeah. It is. I mean, I think like really basic usages, like the very first example I showed you of counting words, it doesn't really matter that much for something like that. I mean, yeah, it allows you to write one line of code instead of 4. In the grand epic arc of your career, will that matter that much? I'm not sure it does. It matters, but not quite 0, but not massively. What does matter massively or significantly is learning the design decisions that came into this, why it provides great value. Because remember, when something is added to the Python standard library, literally millions of computer programmers will have the opportunity to use it. So if you improve default dict by a small amount, just imagine what a tremendous difference that makes in our profession. And I want you to start thinking about your own opportunities to write code that other people will use, even if it's just one coworker, because that makes a difference.